Hello, and this is the screencast for Chapter 22, Managing Our Wastes, and we're picking up at incinerating trash reduces pressures in landfills, where hopefully we've left off in class. If not, we're just a little bit ahead of that. So in this part, we're going to talk about the benefits of incineration and the process of incineration. We're going to talk about how we can get energy from incinerating, and then what else we can get from landfills. We'll talk about reducing our waste as our best option and some strategies that we can use to do that. And maybe we'll get to composting. We'll see. Okay, so let's talk about incineration, and as you can see on here, it's a controlled process that burns garbage at very high temperatures. The combustion of this is, as we said, controlled. I was hoping that wouldn't happen this time. Sorry. The waste is generally sorted and metals are removed. So that means that they're going to go through all of the waste products and separate what cannot be incinerated. Then they're going to take the metal-free waste and they're going to chop it into tiny little pieces, small pieces, and that will aid the combustion process. And then it'll be burned in a furnace. When we take a look at the final totals, incinerating the waste reduces it by about 75%. It also takes some of that moisture out, all of the moisture out, as a matter of fact. And it reduces the volume by about 90%. So the ash that remains contains toxic components and must be disposed of in hazardous waste landfills. When the trash is burned, there's hazardous chemicals like dioxins and heavy metals and PCBs that are present. So this can be created and released into the atmosphere, so we need to be careful about that. And these emissions can cause a backlash, especially among citizens, because they're concerned about the different health hazards that can happen as a result of burning the waste products. But I'm sure from what you're all bright and what you can surmise from this, in developing nations, they now regulate these incinerator emissions. And they have banned, some places have even banned incineration outright. But now there's new technologies that help us to use these wastes for energy. There's a method called scrubbers, which chemically treat the gases produced in combustion to remove hazardous components, to neutralize acetic gases like sulfur dioxide and hydrochloric acid, and it turns them into water and salt. So that's one process. The way that they do scrubbers is usually by spraying liquids formulated to neutralize the gases or by passing the gases through a dry line. The particulate matter that is produced from this is called fly ash, and fly ash usually contains the worst dioxin, the most heavy metal pollutants, and that are found within the incinerator emissions. Facility may use a huge system of filters that are known as a bag house to help remove that fly ash. Burning the garbage, also at the high temperatures that they burn it at, could also reduce certain pollutants or destroy them, like the PCBs. Even all of these measures, however, do not fully eliminate the toxic emissions. So this is what an incinerator would look like. And what you're seeing here is what they have is waste to energy facilities that we're going to be talking about next. They take this waste that's in a storage pit, they pick it up in a crane and they put it into the fire and they burn that fire. They have water going through pipes that the fire turns into steam, and then that steam generates a turbine, which puts energy into the generator, and then that can be sent out. So that's one of the processes that can be done, and that's known as waste to energy. So there's facilities that have that. Here's the bag house that we were mentioning before, and that bag house is going to filter some of the airborne particulate matter. It has come from the scrubber, and the scrubber is what's going to help treat chemically the substance that needs to be. And then you're going to get some smoke that's going to come off of that smokestack. What is left, that toxic waste that's left, is then going to be taken to a landfill and disposed of. So you heard me mention the waste to energy, and initially when we started to incinerate, we just did this to reduce the volume of the waste, but we saw that the energy produced, the heat energy produced, could be used to create electricity. So now there's about 150 waste-to-energy facilities that operate across the United States, mostly in the Northeast to the south, and they have a total capacity to produce nearly 100,000 tons of waste per day. The revenues that they get from the power generation are usually not enough to offset the price or the financial costs of building these incinerators and running them, because it can take a lot of years before a facility can become profitable. And they have to rely on companies having a contract with them and guaranteeing the facility a minimum amount of garbage in order for them to run. So this is a long-term commitment, and sometimes companies don't like the long-term commitments with the communities. So they have to look for subsequent efforts to reduce their waste through recycling and source reduction. But overall, we're seeing that these wastes generate approximately 35% of the energy that we would even get from coal. So it is a good alternative source. Another thing that we can do with these landfills and collecting energy is that natural decomposition is going on within the landfill. There's bacteria that's present. And through that decomposition that's going on in the organic and oxygen deficient environment, what's going to happen is it's going to produce this landfill gas. And the landfill gas is a mix of gases, and about 50% of this gas is methane. So we're able to collect that methane gas and process it just like we would natural gas. So at parts of Fresh Kills, the city of New York City sells the gas for about $12 million per year. And then that energy is used to provide energy for 22,000 homes. So when not used commercially, the landfill gas is burned off to reduce odors and greenhouse emissions. And that's what we saw at the Warminster Wastewater Treatment Facility, where it was being burned off at that last digestion tank that we were looking at. Okay, so we talked about source reduction a little bit, and this is just preventing waste in the first place. So if we reduce the amount of material that enters the waste stream, then we can avoid costs. We can avoid the cost of disposal, and we can avoid the cost of recycling. It also is going to help us to conserve our resources. We're going to be able to use those materials that we've already extracted from our our natural resources, and we're going to be able to recycle them into the products that we need so that we do not have to extenuate any more products from those natural resources. It minimizes pollution. It also saves consumers and businesses money in order to do this. So when we source reduce, there's some definite advantages to that. One of the things about source producing, and we talked a little bit about this, source reduction, we talked a little bit about this in class, was lessen the materials that are used to package. And not only for the devices and things that we buy, but other goods, our food. Typically we do packaging to help preserve freshness, to prevent breaking, to protect against tampering, to provide information because we put information on the labels. But that packing is extraneous. It's not all necessary. So consumers need to choose minimally packaged food, or if they're going to buy something from produce, then they need to buy unwrapped fruit and vegetables, or buy their food in bulk is another advantage. From the manufacturer's standpoint, we can switch packaging that is more recyclable. We can look for materials that we can recycle back into other products for that. We can also reduce the size or the weight of the goods and the materials because that cuts down on the packaging. And we've done this for aluminum cans to plastic soft drink bottles. I think you know the difference. There are some soft drink bottles that are very, very flimsy and others that are very sturdy. And we can make them a certain grade, and that would be saving as well. Another form of waste that everybody is getting on the bandwagon with is litter. And one of the biggest problems with litter these days are the plastic grocery bags that we use. These lightweight polyethylene bags can persist for centuries in the environment. They don't degrade, and they wind up choking and entangling wildlife, and they litter the landscape. Americans discard about 100 billion of these plastic bags a year. So because of that, there has been a number of major cities and over 20 nations that have now enacted bans or limits on their use. In 2007, San Francisco became the first U.S. city to ban non-biodegradable plastic bags. The city's action now has saved 14,000 bags every day. Stores are even giving financial incentives if you bring your own bag. I know that Giant does that. They give you 10 cents for every bag that you bring in and that you use off of your bill. So there's companies that do that. Ireland started to tax their bags, and when they put tax on their bags, the bag use dropped by 90%. IKEA has followed suit. They began charging for the bags, and they saw a similar droppage in use. And now, as I said, an increasing number of stores will give discounts if you bring your own bag. Another thing that they're looking for is increasing the longevity of goods, because that also helps to reduce the waste. If you make a product that's going to last longer, then it's not going to wind up being in the trash. But companies, they want to make a product that's going to fail within a short period of time so that you'll buy another one, and that keeps the profit up. So in order to stop that demand, consumers are going to have to demand manufacturers make better products so that manufacturers will respond. Okay, we're going to end here. We're not going to be able to get into reuse, but we'll stop here and we'll pick up from that in notes tomorrow. Bye.